Alright, so it's already 11:35. So can you guys see my screen now? Hello?
Yes, sir.
Is my voice clear? Is it loud enough?
Yes, sir.
Yes, sir.
Okay, okay. So again, you guys can
Yes,
eat.
sir.
Okay, thank you. So again, you guys can eat while listening. Alright, so are you guys ready now to listen with our continuation module 4? So how about giving me a thumbs up if you guys are already ready, or just to let me know that you guys are already in front of your computer. Okay, very good. 4, 5, 6, 7, 8. All right, so at least half of you were already in here. All right, so last meeting we were able to finish the slide 1 up to slide 34, or half of the slide 34. So we have already answered example number 1. So we will now answer example number 2. All right, so again in here, in converting a hexadecimal to binary, so you can do it separately, okay, or by character. So from here we have whole number, and then at the same time we have decimal. So you can do it one by one. Like for example, right here, the 3 right here is represented by this binary. So again, in binary, going back to our representations of 4-bit before. So we have 4 bits, right? So the less significant bit is 1, and then the second is 2, the third one is 4, and then the last one is 8. Okay, so if there is more, then this one is already 16. Okay, so it just keeps on doubling. Okay, this one is 32. All right, so in here in hexadecimal, we only need 4 bit. Okay, so up to 4 bit only, every character or every bit. So as you guys can see right here, we need 3, so we need to activate 2 and 1. Okay, so that is why we have this value 0, 0, 1, 1. Okay, we need 2 and then 1. So 2 plus 1 is equal to 3. Okay, so were you guys able to follow so far with this one? 0, 0, 1, 1. Okay, good. And then of course for 0, okay, so you don't need to activate anything since it's a representation of 0. Okay, and then for 6, so we need 4 and 2. So it's represented by binary 0, 1, 1, 0. Okay, 4 and then 2. And then for the D right here, so in hexadecimal or in decimal, this one is 13. Okay, so going back to our representation, so 10 is A. Shh, sorry for that. My cat is playing with his house. So 11 is B, and then 12 is C, and then 13 is D. So in here, we need 13. Okay, so in binary, for you to be able to have a 13, so you need 8, 4, and then 1. Okay, so this is the representation of 13 in binary. So yeah, same. So 1, 1, and then 0, 1. So again, you can remove the two zeros in here. So actually, you can already have this one as your final answer. But if you want to have a shorter or much more simplified answer, so you can remove the 2, 0. Shh, just wait a second, guys. All right. So from this one into this final answer. Okay. So nothing's new. If you have the period in here or the decimal, then put the decimal in here also. Okay, and then of course you have to put the unit. Okay, So this is an indicator that you have already converted this hexadecimal into a binary. All right. So are we clear with this one so far? Were you guys able to follow? Okay, good. How about the others? All right, great. So I hope to the others who didn't respond. So if you're having a hard time in understanding this one, so feel free to message me anytime, or you can ask it right now actually, so we can discuss it as soon as possible. All right. Okay. So next one right here. If we have hexadecimal to binary, well, of course we can reverse it. Okay, from binary to hexadecimal. So in here, of course, it will give you a binary combination like this, and then you have to convert this one into something like this. Now, the first step that you need to do once you've saw this one, and then it is asking you to convert it to hexadecimal, you have to group it by 4. Okay, so why by 4 only? Because in hexadecimal, okay, just by having this 4-bit, you can already accommodate uh, from 0 up to 15, wherein 0 to 15 is hexadecimal. Okay, so if let's say you'll group that one by 5-bit, that is not hexadecimal already. Okay, that is already I'm not mistaken, 16, yeah, 17. That's already n base, or we call that one 17 base. So remember, in hexadecimal, it's only a 16th base. Okay, so you don't need 5-bit for that one. Okay, you only need 4 bits from 000 to 1111. Okay, that's the range of the hexadecimal, 0 to 15. All right. So in here, just group it by 4, starting from the rightmost side. Okay, this one is already this one, and just count for 1, 2, 3, 4. So it's this one. So just put one space for you to easily identify each group, and then another 4-bit, which is this one, and then another 4-bit, which is this one, and then we have 2 bits. So in here, in order to complete the 4-bit group, so just add 0, 0. Okay, so it will not affect the value of this one, since those two are zeros. So from here, you can now read the values of this one by one. So 0011 is 3, 1001 is 9, so 8 plus 1 is 9, 0101 is 5, 0101 is 5, and then 1101 is 3. And then from here, you can now combine everything. And then wherever is that decimal point is, so just put it where it should be. Okay. All right. So coming from Mr. Brenjan Pasito. Sorry, sir, unstable network, disconnect. Uh, I guess it's okay, Mr. Pasito. So just try your best. If whatever you can understand, it's okay. You can watch the recorded video anyway. Let's say you've missed that part, so you can uh, watch na lang. Okay? Since wala na tayong magagawa kung unstable yung network. So there are really, times wherein our internet connection is not stable. All right. So were you guys able to follow this one? And how did we get 3955.d? All right. So very good, Mr. Giovanni. Mr. ba or Miss? I guess Mr. How about the others? Hello. All right. Okay. Okay, maybe 3 or 4 of you were able to follow. So I guess the others who did respond also were able to follow this one. So again, from binary to hexadecimal, you must put, okay, you must not forget the unit. Okay, this is an indicator that you have already converted this binary into hexadecimal. All right. So we also have here octal to binary. Okay, so this one is represent each octal digit to 3 binary digits. So before in hexadecimal, we need 4 bit, but in octal, we only need 3 bits. Why? Because if you guys are going to take a look in this one, so this is 0, and then this one is already 7. So take note, in octal, we only need 8 characters, okay, starting from 0 to 7. And then if you will exceed to that one, let's say 1000, this is not octal anymore. Okay, this is already ninth base or n base, or yeah, that is the other term for this one. But this one, to be exact, is ninth base. Okay, so in octal, it's 8 base only. Okay, so that is the reason why we only need 3 bits for the octal. Okay, no, not 4 bit, because 4 bit is for hexadecimal. So from here, as you guys can see, 5 is 101. So 1 plus 4 is 5. And then from here, of course, if it's 7, then just activate everything. Okay. 4 plus 2 plus 1 is equal to 7. And then for the 1, so you only need to activate the 1. Okay. So in here, it's 0, 0, 1. All right. And then from here, again, you can remove the other 2 0, and then it will lead you to this much more simplified answer. So again, you must not forget the label or the unit, wherein this is octal, and then in here it's already binary. So this is an indicator that you have already converted this octal into binary. All right. So are we clear so far? So just give me a quick thumbs up if you guys were able to follow this one without a problem. Okay, 1, 2, 3, 4, 5, 6. All right, so at least half of you were able to follow. All right, next, of course, if we have octal to binary, you have the converse of that one, or the inverse. Okay, we have binary to octal. So of course, it will give you again this kind of binary combination, but instead of grouping them by 4, so you have to group them by 3 since we are in octal. Okay, so the same process with the hexadecimal. Okay, so 1, 2, 3, and then this is now the 3 bit, and then another 1, 2, 3, so another 3 bit, another 3 characters, another 3 bit, another group, which is another 3 bit, and then another group, which is another 3 bit, and then uh, we have 2 bits in here. So just to make it much more formal, since we are representing this one by 3 bits, so all you need to do is add a 0. So again, it will not affect the value of this one since this one is 0. And then from here, you can now convert those binaries into octal, okay, one by one. So this one is a value of 3, this one is 1, this one is 2, this one is 5, and then this one is 3, and then this one is 5. Okay, so yeah, that's it for the binary to octal. So are we clear so far? Hello? All right, very good, Miss Karil. Very good, Miss Shasi. Very good, Miss Emily. All right, so anyway, this one is super easy and very straightforward. So let's now move on to the summary. So here are the things that you can do with the decimal, binary, octal, etc., etc. Okay. So there are things that you need. You need double or triple conversion. Like for example, in here it is asking you to convert octal into this, let's say, base. So you cannot convert it, as soon as possible. So you need to convert it to decimal before you can convert it to n base. So yeah, sometimes you need double or triple conversion. Okay, so there are situations like that. So this one, supposedly this will serve as your assignment if we are in a face-to-face method. Then again, since we are in ODL, so I will not give this one to you anymore as your assignment. So I'll just leave this one as your practice assignment. Okay, so you don't need, oops. Okay, so you don't need to do this one. Okay, this is not a requirement. Okay, for you to finish. You know, just a practice to enhance your conversion method from octal to binary and bring it back to hexadecimal and so on and so forth. Hexadecimal to binary and then the binary to octal, etc. All right. So the next one right here is operations on numbers. So we'll talk about binary, octal, and then hexadecimal. So let's talk about binary first, or binary addition. So in here, binary addition is very simple. Okay, as you guys can see, 1 plus 1 is 10. 1 plus 1 plus 1 is 11. 1 plus 1 plus 1 plus 1 is 100. So you guys might be wondering how that happened. But if you guys are going to take a look on this one, so 1 plus 1, in a conventional way of solving this one is 2, right? Ano yun? Mr. Giovanni? Saan yung part na paulit? This one? Okay. Alright. So going back here in binary addition. So again, 1 plus 1 is 2, right? This is the normal way of solving addition. Okay. However, again in binary, we don't have 2, okay? Because this one only has a value of 0 and 1, okay? So if you're going to convert 2 in binary, so you can represent this one by 0, 0, 1, 0. Okay, this one is in a form of a binary. And if you guys are going to take a look at this one, you can actually remove the 2 zeros, so it will not affect the value of this one. But then 2 is represented by 10. So that's how we've come up with that 10 in here. All right. And then from here, if we have 1 plus 1 plus 1, 1 plus 1 plus 1, this one is actually 3, right? But in binary, so you have to represent this one in a 4-bit group or 4-bit binary. So in here, we need 0, 0, 1, 1. Okay. And then from here, you can again remove, ano palitin, so we can have more space. Anyway, so in here, you can remove the 2 zeros wherein it will give you 11 only. So that's how we've got that 11 right here. Can you guys follow so far? Okay, very good, Mr. Pasito. How about the others? Okay, very good, Mr. Adrian. Okay, very good, Miss Karil. Okay, very good, Miss Kayla. Okay, good, good. Okay, maybe at least 5 or 6 of you were able to get it. Okay, so from here we have 1 plus 1 is 10, 1 plus 1 plus 1 is 11, and then 1 plus 1 plus 1 plus 1 is 100. Okay, again, going back to the binary conversion, so 1 plus 1 plus 1 plus 1 is 4. Okay, but in binary, the value of this one is 0, 1, 0, 0. Okay, wherein again, you can remove this one for you to have the value of 100. Okay, so that's how we've got this 100 right here. Okay, and then of course, if you have more, let's say 1 plus 1 plus 1 plus 1 plus 1, this is already 5. So this one will be represented by 0, 1, 0, 1. Okay, wherein again you can remove this one, so it will give you 101. Okay. So yeah, here's the table for this one. 1 plus 1 is 10, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is, oops, where's this one? 0 plus 1 is supposedly, alright, maybe I'm lost. 1 plus 1 is 10, 0 plus 0 is 0. Wait, 1 plus 0 is 1, and 0 plus 0 is 0. 0 plus 1, okay. So 0 plus 1 is 1, and then right here 1 plus 1 is 10. Okay, so I'm missing this part a while ago. Anyway, so that's how you add binary. Okay, so let's have an example. So this one is super easy. Let me just get this one. All right. So from here, okay, so 1 plus 1 is 10. So carry 1, bring down 0. So this carry will be added to this one. So 1 plus 1 is 10 again. So carry 1, bring down 0. So in here we have 3, 1. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 1 is 10. Carry 1, bring down 0. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 1 is 10. So carry 1, bring down 0. And then bring down that 1. So this is now your final answer. Okay, clear so far? Okay, very good, Mr. Remji. How about the others? Were you guys able to follow on how did we get this answer? Okay, great. Okay, very good. Okay, so let's have more example. Okay, let's get this one. There you go. Oops. Let me remove this one. There you go. Alright, so 1 plus 0 is 1. 1 plus 1 is 10, so carry 1, bring down 0. 1 plus 1 is 10, carry 1, bring down 0. And then, oops, 0. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 plus 1 is 11, so carry 1, bring down 1. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 plus 1 is 11, carry 1, bring down 1, and then bring down this carry right here. Okay, so we have an answer of 11001, 0001. Okay, let's compare. So 11001 and then 0001. Okay, so clear so far? Okay, great.
Yes, sir.
All right, very good. All right, so number 1 and number 2 is almost the same. However, what about if we have number 3 as our example? So let's try to answer this one. Okay, so right here, so 0 plus 1 plus 0 is 1, so no problem. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. 1 plus 1 plus 1 is 11. So carry 1, bring down 1. Now, what about this one? 1 plus 1 plus 1 plus 1. We have 4. What is the representation of 4 again in binary?
100.
100. Now, how do we put this 1 and 0 right here? So we can already bring down this 0. However, how do we put the remainder in here? I mean the carry, not the remainder. Carry. Is it 10 as it is, or we need to separate it like this? Is it as 1 or separate? Which one? So this is the 1 carry, and then this is the separated carry. So this one will go here, and then this 0 will go right here. Anyone who has an idea? Okay, so coming from Mr. Ranjan, Pasito, so separate. Yes, actually you're right. So you need to separate it. So 0 will go here, and then 1 will go on the other side. Okay, so we have 2 carries in total. So in here, 0 plus 1 plus 1 is 10. Okay, so carry 1, bring down 0. And then from here, we have 1 plus 1 plus 1 is 11. So carry 1, bring down 1. Okay, so 1 plus 1 plus 1 plus 1 is 100 again. So you have to carry here the 1 and then 0 right here, and then another 0 right here, which is 100. 1 plus 1 is 10, so carry 1, bring down 0. And then 1 plus 1 plus 1 is 11. Carry 1, bring down 1. And then 1 plus 1 plus 1 is 4, 1. So 1 plus 1 plus 1 plus 1 is 100. So carry 1 right here, carry 0, and then bring down 0 right here. 0 plus 1 is 1, and then 1 plus 1 is 10. So carry 1, bring down 0, and then bring down that carry right here. So that is the answer for the number 3. Okay, so I hope you guys were able to follow with this one. Are we clear so far? Anyone who's confused? All right, so very good. Miss Emily and Mr. Miss Shashi Nicole. How about the others? Were you guys able to follow? Okay. Anyone who wasn't able to follow? Okay, it's a good sign then. So at least maybe half of you were able to get it. So I hope the others were also able to follow. Anyway, so let's have this binary subtraction. So binary addition is very simple. So it's actually the same rule in subtraction. Okay, so let's go back with the conventional way of solving things. So 1 minus 1 is of course 0. Okay, but if you have this one, let's say 1 minus 1 is already 0. But then again, there's another negative 1 right here. So 0 minus 1 is cannot be. So you have to borrow on the other side. Okay? So in here, once you borrowed, okay, it will give you 2. Okay? So 2 in binary is 10. So in total, it will give you 10 as a result. Alright, so uh, you know, you might get confused if we'll just keep on talking the concept. So let's have an example right away. Oops. Okay, let me just get this one, and then we'll compare our answer later on. All right. So in here, 1 minus 1 is 0. So I guess no problem with that one. But 0 minus 1 is cannot be. So we have to borrow to your, or to the neighbor of this 0 right here. So this 1 will become 0. And then this 0 will become 10. All right. And then 10 minus 1 is 1. Now, how did it happen again? Because 10 is 2, right? So this is in binary, this is in decimal. And if you're going to deduct 1 in 2, which will give you 1 only, so in binary, 1 is just 1. Or actually, if you want to make it 2 bits, it's 0, 1. But then again, you can remove the 0 right here. That is why 1 is equal to 1. Okay? So, yeah, that's how we've got this 1 right here. Clear so far? Okay, just remember 10 minus 1 is equal to 1. Okay, I think that's the only thing that you need to memorize. Yeah, I know it's quite confusing, but then again, this one is in a form of binary. This one is also in binary. That is why you will get 1. Okay, this one is also in binary. Okay, all right, so from here, 0 minus 1 is cannot be, so we have to borrow again, wherein this 1 will become 0, and then this 0 right here will become 10. 10 minus 1 is 1, 0 minus 0 is 0, 1 minus 1 is 0, and then 1 minus 0 is 1. Okay, so let's compare our answer. So right here, we have 100,110, okay, which is the same with this one. Okay, clear so far? Okay, how about the others? Now, if you guys have a problem or wasn't able to follow, please let me know as soon as possible. Okay, so we can go over with that one and then discuss it again. Yes, Miss Zulueta, Miss Kyla, do you have a question?
Answer.
Okay, baka na-misclick lang. Anyway, so that's it for the binary subtraction. So let's have more examples. So I will not answer number 1 anymore since this one is quite the same with this one. What we're going to answer is this number 3 right here. Okay, oops. All right. So from here, this one will, become quite messy since we're going to borrow a lot. We're going to change a lot of numbers from 0 to 1, 1 to 10, etc. etc. All right, anyway, so 0 minus 1 is cannot be. So we have to borrow. So this one will become 0. Okay, let me just use the white one. 1 will become 0. And then this 0 right here will become 10. Okay, so now we can subtract 10 minus 1. 10 minus 1 is 1, minus 0 is still 1. All right, and then 0 minus 1 is cannot be, so we have to borrow. But we cannot borrow yet since this one doesn't have anything. So this neighbor has to borrow to his neighbor for him to be able to give something to that someone who is borrowing, let's say, a money. Okay, so we have to change, or we have to make this 0 right here 10. Okay, wherein of course this one now will become 0. Okay, so right here, this 0 now can borrow to this 10 right here because he has now something that he can give to. So this 10 will become 1. Okay, and then this 0 now will become 10. So from here, 10 minus 1 is 1, minus 1 is 0. Okay, so I hope you guys were able to follow with that one. So yeah, that's how we do it in binary subtraction. However, let's proceed. So 1 minus 1 is 0. So let's now cancel this one out, the same with this one. So we now have 0 right here. So 0 minus 1 is cannot be, so we have to borrow. But then again, we cannot borrow to this guy because he doesn't have anything. So we have to make this one 10. Okay, so of course we have to borrow to this another neighbor. So 1 will become 0, 0 will become 10. So now we can borrow to this guy since he has now a money. So 10 will become 1, and then 0 will become 10. So 10 minus 1 is 1. Okay? All right, so can you guys still follow? All right, so some of you maybe. All right, so we'll repeat it later. Okay, since we don't have enough time anymore. Okay, so we'll just continue this one later on the part two. Okay, so goodbye for now and see you guys on the part two.